record one session. Okay, so I'm presenting an example of a wearable enhanced learning training in AR for senior patients with hypertension. The project is called Beware, and it is a project funded by the German Ministry of Education and Research. It actually ends next year, but we are still experimenting. We found it super interesting to experiment with AR and VR design for learning and training for senior patients as a target group. And the key research question for us is how we can use wearable sensors, how we can use AR technologies to create trainings, physical trainings for seniors to enhance their well-being, fitness, and so on. So what we are doing is really something that we think might come in the future, because in our project we have tested, for instance, the different AR glasses and the different wearable sensors, and we have still found that there are many limitations. Some simple things like cables, battery lives, and all these that we think it's, what we are doing is really something that can be fully implemented, seamlessly implemented in years to come, because the technologies, the hardware are not really there yet. What we are doing there is we are designing the training in AR. The focus is on interaction design, on gamification on one hand. On the other hand, we're using different wearable sensors and using machine learning methods and capturing movements of people to model the movement of the user in AR and the movement of the trainer, and develop different scenarios how trainer avatars, user avatars can interact in a AR environment to fully benefit from those technologies, basically. These are the partners. I work at Boyd University, which is on the right-hand side, and we are responsible, one research group is responsible for motion capturing and machine learning, and my team is responsible for interaction design and gamification, and we do this together with Artcom Studios in Berlin. These are the technologies that we use. We use different sensor data for health-related, to capture health-related data, like for instance, blood pressure, pulse, but also the different movements of the seniors, of the patients when performing different kinds of movements. And we use different augmented reality and also virtual reality glasses. This is the architecture. You can find this also in the paper, and you can see that the sensors are the core components of the system because they supply the data about, for instance, the motion, the heart rate, the blood pressure. And why we're doing this is to promote healthy aging and well-being of patients with hypertension. I'm not going to go into the details of the different components, like we have a training application, the simulation, the assistance system, and a dashboard backend for trainers to design different trainings, like for instance, dancing, what do you call it? Press, overhead press, and all the others. I'm going to present some examples later. We also use sensors like this, the smart insoles by Moticon Science, which basically enable to compute the pressure information of the foot movement. And they give us information about the center of the gravity of people performing different exercises. And in this way, we can analyze the data and see if there are any discrepancies between the ideal model in a specific exercise and the actually performed activity by a user. We have conducted different focus groups studies, but we haven't tested our MVP yet. This is going to be done in October, so that's why in the paper we still don't have really extensive data from testing. But we just did a focus groups and interviews with senior patients, and we found out some of the preferences of the senior users in relation to using wearable technologies. So for example, we tested HTC Vive and HoloLens to compare how seniors perceive AR versus VR and which one they like, which option they like more. And we found out that seniors like AR much more because they fear that in VR, where they don't see the real environment, they may fall down, for instance, or trip against the table or something like this. They also prefer the real environment in AR with displayed information about their data compared to some kind of illusionary environment. We thought this could be interesting because based on the interviews that we did with seniors, they said, for instance, they expressed their preferences for specific games, movies, and we thought creating an illusionary environment could be very attractive for this target group. But in the end, we found out they really prefer the real environment with displayed information. Also, senior users told us that they prefer the use of controllers to operate the system as opposed to gesture control. They also prefer multiple user or gamer mode compared to single player mode. We haven't been able to develop this multiplayer mode yet, but we are working on, or we will be working on this in the second part of the project. And also senior users said that they prefer the feedback from the system, the feedback that compares their own results as opposed to feedback comparing them to other users. So they don't like this option, comparing themselves to others. So based on all these information and much more from interviews and focus studies, we designed our personas. We have 3 personas. I can only see 2 just to have an impression of who the users of this augmented reality training system are. They have different medical diseases, different health issues that we try to address in the design of trainings and in the motion capturing too. We have conducted a series of ideation workshops where we try to understand how senior users interact with the different information that will later be presented in AR or VR, and how to design different elements of the interaction design so that it's understandable to senior users. So you can see some pictures from those workshops here. And we have also worked on the trainer's avatar with a question how to design the trainer's avatar in VR and AR so that the senior learners feel motivated, engaged, and they have a feeling that there is a person actually supporting them in their learning process. So we came up with this design of an avatar. It's one of the avatar designs that we have that we foresee for the project. It's a female figure, Anna, who is basically performing different movements in AR, and the user is supposed to follow the steps of the trainer and receives feedback from the avatar. So you have seen the slide before. This was the first version. Now this is the next version that we're going to test in October. We already see the room because the scenario that we develop is to use the entire system basically in the surroundings, in the living environment of the end user. So it will not be a fitness studio or a special room where the senior person would go, but it will be just in their own house, for instance, in their own room. And one of the first gamification designs that we created was to gamify the dancing training unit. And we did this based on the Saturday Night Fever scenario, which proved to be very successful and engaging to the users. So basically, the room of the person changes to the dance floor from the 1960s, and the user can dance like John Travolta. That's the challenge that they have to engage in. And then there are different gamification elements, like you can see on the right, the different points that they get and so on. We have followed the recipe model for meaningful gamification to design this, and we're going to also work further on those in the next iterations. And last semester in the lockdown time, my students also worked on designing gamification designs for other training units in this project. I'm just going to show you some examples of how they did this. I think they're really interesting things. Like, for instance, you can see here, the upper part is the non-gamified scenario and the gamified one is in the lower part. So we were kind of thinking how to make, for instance, the overhead press more engaging, more fun, and how to use the different elements in AR to display additional information. Then we have another exercise like high five, where the students propose to use the Ipson glasses and the Bebop sensors for the hands, so that the users can perform specific movements for high five, which are important, one of the important training elements in the entire system. Then, for instance, we had some other ideas for designing avatars, not only as persons, but also as animals, for instance. So we're going also to test this. For instance, a dog that you can play a ball game with. And another one using a virtual mirror to mirror your movements in AR, having a trainer figure and also a mirror where the patient can see themselves performing, for instance, the squat or other types of exercises. So in the next phase of the project, we will be thinking and designing the gamified versions of the different training units. We decided to use the Vive, HTC Vive for further iterations. And we hope that in the end, we will have some nice MVPs for different training units that will be engaging and motivating for senior users to engage in this kind of training. So that's what I wanted to share with you. And I'm happy for questions. If there are any.
Thank you, Ilona. Are there any questions?
I have one. You said you modeled a female avatar only, right?
Mm-hmm. So far, yes.
Why didn't you have both sex avatars?
This was also something that came up from the interviews and focus study groups. We asked different questions, and and actually they wished for a female avatar. But we're also going to see now in the October testing if it is actually the design that the seniors wish for. So we still have some questions, and we're basing this on the uncanny valley theory, like how detailed, for instance, the face should be designed, how detailed you should be able to recognize the body of the avatar, and if we are right, using a specific kind of voice tone and also the style of talking to an older person. So we're going to test all these details in October.
So what's your take on the uncanny valley? Photorealistic or abstract? Or where do you think it will be going?
Yeah, I think this kind of abstract silhouette is probably really nice, because this is what we got positive feedback from like single users so far, and also everybody in our team kind of likes this kind of avatar where you don't see the color of your eyes or whatever. You just see, okay, you can recognize it's a female figure, and that's basically enough. It allows you, I think, more to focus on the training itself, other than looking at and focusing and paying attention to the details of the body or the details of the face.
But it still is a 3D avatar, because I wasn't quite clear from the snapshots you were presenting.
Yeah,
whether it's
yeah.
It's 3D. Okay.
It's 3D. Yeah.
That wasn't very visible. So individual users gave good feedback so far. I had another funny question, especially since you're testing extensively with seniors. One thing I've noticed with the HoloLens in the past is that people who have age presbyopia, I suspect, walk backwards.
Mm-hmm.
They start weirdly, just slowly walking a little bit back, so as to kind of step away and see it better. That's a little bit my impression. Mm-hmm. Have you noticed something like that too?
To be honest, I don't know, because I'm not doing the testing. These are our partners at the university, medical university. They work in the research group, geriatric research group. and they do all the testing with the senior users. So we, the other design partners or development partners, we don't really have access to the group. So I cannot tell, unfortunately.
After, it would be interesting to find out.
Yeah.
It's something I noticed, and the only explanation I have for it is age presbyopia. That when people get a bit more long-sighted with age, that they instinctively want to step a little bit back and see it better. Or it may also be that it's their way of acting with the display sizes. With young people and kids, you do not have that at all. On the contrary, they're much more like going close and trying to touch things and holding up. And for old people, it seems to be this. It may be a cultural artifact that they're just trying to step away to see everything because the display is limited. But it may also be something to do with the emergence accommodation conflict. That you still are aware that it's here and not in space. I don't know, I haven't gotten to the bottom of it, but I find it puzzling. And it would be very interesting to find out why that actually happens, or if that happens with you as well, or whether it's just our devices or our lighting or the rain in the UK.
Thank you. I took a note of this. I will forward this to my colleagues at the medical university.
Okay, so more questions? If not, I would have also a question, Ilona.
Sure.
You mentioned human activity recognition and machine learning. So how far had you come with that? Is that those activity recognizable, what people are doing in augmented reality from like multi-sensory input, or so that's the question. So is it recognizable?
Yeah. So I don't work on this. This is another research group at my university that specifically focuses on the motion capturing and modeling and machine learning. But from what I know, it wasn't, or it hasn't been a very easy process, especially because of the data transfer issues, like the synchronicity of data transfer to the system. So I remember from what the colleague said is that when you use the different sensors, like you have the sensors on your wrists and you have the insoles and so on, to combine all these data sources and to feed them back into the system, that has been very complicated. And I don't think it's already there. I think they're still working on it. So that was one of the issues that I picked up. But I personally don't work on this myself, so I cannot give you the details.
Yeah,
but there will be a paper from them coming, sure.
I would like to get in contact with your colleagues. So
yeah.
Thank you very much.
And the insoles that you're using, how good are they really? If you give us your honest take. I mean, it looks cool that you can calculate it from a single point, sort of. But I mean, how error prone are they in showing you?
So they have been calibrating this as well, like the last weeks or months, and it's still not ready yet. But we're actually, so I also cannot say how well it will be able to integrate this into the system. But the colleagues are really enthusiastic, and the results that they got, they're specifically for the research, and we're planning to design gamification scenarios based using the insoles. So we're going to do this in the fall when the data is transferring and is integrated.
The interesting tip, by the way, I have been exchanging with Roland from, where is he, in the States, Michigan, I think, a while back, who did this fantastic AR installation with the ping pong, I think it's called, where you have a projection on the pedestrian asphalt, and people can, with their shadows, play basically, or ping pong or something. And he has been thinking a lot about somewhere aesthetic things, where kind of the bodily feeling comes together with the aesthetics of visualization. And we always wanted to pursue a thing which I even had a student for who then ghosted, an art student. We wanted to develop some dancing shoes, which I think your project would be perfect for.
Yeah.
Work with that idea that you can actually integrate something like a pulse that visually, like a music visualization that integrates into your environment, like you already have with the disco.
Yeah, exactly.
But use that to make people move in specific ways. If the souls even had an actuator, or you can simply put one in to make them vibrate.
That's a good
you could
idea.
use that as feedback to make people dance, essentially.
Okay, Fridolin, I think we need to move on. Yeah. So.
Yeah, that's a good idea. I'll also took a note.
Sorry for that, but I think we need to announce the next paper.
Yeah.